Hey, my name is Fahad. I'm going to be demonstrating the compilation, process management, second behavior, and client message handling with design trade-offs of my MySH shell project for CC29. Let me first start by showing you the mysh.c file. This file contains the shell control loop. The key sequence is, well, the way it works is it follows a sequence, reaps the children, firstly, then it pulls network input, then it prints the prompt, then reads input. That is the event-driven loop that I have decided to use. This ensures the shell remains responsive. Now let's run the project. Now let's compile the project actually. Make clean, make. The project has compiled cleanly without any warnings or errors using the flags required. Now let's run the project. Run the shell and perfect. The shell is running. Now let's run a command like oops sleep 30%. Whenever we want to create a background process, the shell immediately prints a job ID and PID, showing that the process was registered in the job table. Now if you run PS, it shows that the built-in PS lists active jobs tracked by the shell instance. We can run the kill command. Kill, then what is the 796 575? Perfect. Yes, perfect. When I terminate that process using kill, by default this send sig term. You can also pass a specific signal number as a second argument. When the child is reaped, the shell prints a done message. This confirms non-blocking child status checks are working. I wanted to go over commands.c for a second. Control F. BG. No, not here. One second. Yep, perfect. Here. This section implements background jobs, add BG jobs, and inserts jobs. Then let me show you display. How do I display jobs? Display the processes. Display processes powers PS. Finally, okay. Catch children uses non-blocking wait to detect finished jobs and prints done notifications. Now let's go back to my sh.c file to explain something else. Oops, no. Come on, bro. Second hand, perfect. So here's the second handling. The shell handler never kills the shell itself. It records interrupt states and coordinates with foreground process handling. Let me actually go back to commands.c. Control F. Yeah. Okay. If a foreground child exists, SIGINT is forwarded to that child. This preserves expected Unix behavior. Interrupt the running command, not the shell. Now let's go back to the shell here. Let's type in Control C. Yeah. During foreground execution, Control C interrupts the child command. This shell remains alive and returns control to the prompt. So let's say we run 30 ampersand. It is running, but now if we do Control C, we see that the command has terminated, has been interrupted, but the shell remains alive. Let's start a server. Start server 5000. 1 second. Start client 5000. 127. Okay. This starts a client connection. All of the incoming client data is pulled without blocking interactive shell input. So if I type in hello, there we go. Perfect. A normal message is received and broadcast with a client identifier prefix. We can try any message that's longer than 128 characters. Very long messages are rejected with error. Message too long, that's the error message. This enforces bounded input and avoids any unsafe payload handling. So let's try that out right now. If I did hello with a lot of O's. Okay, I think that should be enough. Yep, error input 9 too long. Now let's go back to command.c. I gotta show you something else as well. Send. Where's no? 1 second. No. Maybe I should use the other search. Yep, there we go. Okay, this is the message validation path and select based server loop. It shows explicit length checks and multiplex socket handling. Let me actually show you one more thing. There we go. Okay. Max str length is defined here as 128. This single constant drives command and message size constraints. Maybe I can go show you guys variables.c. We're able to use a dynamically resized array with capacity doubling. It is simple and efficient for moderate sizes, but lookup remains linear. Now let's return to the terminal. Perfect. Okay. In summary, this shell demonstrates strict compliance, hygiene, practical process control, correct SIGINT semantics, and robust bounded message handling with clear system design trade-offs. Variables.c. Yeah, that's basically, I've covered everything. Maybe I can go over some cons of variables.c. Variables, how I store variables. Every time the array reaches capacity, it will double. Ideally, you don't, which means it allocates memory for that many variables, and the size can get large pretty quickly. However, there can also be a lot of space that is not actually used. Other than that, lookup remains O of n, and this is simple and efficient, so that's one of the pros. Okay, I think I've gone over basically everything else. Thank you for listening. Have a great day.